we will discuss different terms which are used in the digital electronics. Number one, Minterm, then Maxterm, then basic theorems and postulates of Boolean Algebra, and some examples related to the simplification of a Boolean function. First of all, I define Minterm. It is AND form term is called the Minterm. For example, x, y dash, z, a dash, b, c dash. The minterms, a minterm is represented by small m, and there is some number in the subscript. For example, m2 and m8. m2 is the minterm corresponding to the binary code 2. Similarly, m8 is the minterm corresponding to the binary code 8. In case of minterm, if there is one state, it is represented by the uncomplemented variable, and if there is zero state, it is represented by the complemented variable. Then we have Maxterm. A Maxterm is the odd form term, and it is represented by the capital M. A Maxterm may be a plus b dash plus c, x plus y plus z dash. Now, if we have one state, it is represented by the complemented variable, and if we have zero state, it is represented by the uncomplemented variable. Now the Maxterm M0 represent the Maxterm corresponding to the binary code 0000, and M1 is the Maxterm corresponding to the binary code 1. Then we have basic theorems and postulates of Boolean algebra. Number one, x plus 0 is equal to x. The plus sign indicates that it is an OR operation, and in case of OR operation, if we have two inputs OR gate and one input is 0, then output is equal to the state which is on its other input. And if there is x on the other input, then we will have x plus 0 is equal to x. Similarly, its b part, x dot 1 is equal to x. It represents the AND operation, and in case of AND gate, and we have two inputs, one input has x and the other input has one state, then it is equal to x because the AND gate is enabled. Number 2, x plus x dash is equal to 1. X dash is the complement of x, and it is equal to 1 because we have two states of x. X may be 0 or x may be 1, and if x is taken as 0 state, then x dash is 1 state. So we have 0 plus 1 is equal to 1 because there is OR operation between x and x dash. Similarly, its b part is x dot x dash is equal to 0. Now if x is 0 state, then definitely x dash is 1 state and 0 dot 1 will be equal to 0 because there is AND operation. Number 3, x plus x is equal to x. Now it is OR operation, and if there is x on one input and x on the other input, then x plus x will be equal to x. B part x dot x is equal to x. Number 4, x plus 1 is equal to 1. Now this is an OR operation, and if one input of OR gate is one state, then the output is definitely equal to one state. If an 0 state or 1 state is on its other input. B part x dot 0 is equal to 0. Now it is AND operation, and if one of the inputs is 0 state, then definitely output will be 0 state. Number 5, x dash whole complement is equal to x. If we take complement of a number twice, then it will be equal to the original number. Number 6, x plus y is equal to y plus x. So the order of x and y variable can be interchanged, and it is commutative property. Its b part is x dot y is equal to y dot x. So order may also be changed. So there is no difference. Number 7, x plus y plus z is equal to x plus y plus z. It is associative property. So order of the variable can be changed. So there is no matter. B part x into yz is equal to xy into z. Number 8, x into y plus z is equal to xy plus xz. It is distributive law. B part is x plus yz. It can be written as, in bracket we have x plus y, and in the other bracket we have x plus z. It is distributive property. Number 9, x plus y whole complement is equal to x complement y complement. It is De Morgan theorem. B part xy whole complement is equal to x complement plus y complement. So these two equations, number 9 shows the De Morgan theorem, and in this De Morgan theorem we can change OR operation into the AND operation and AND operation into the OR operation. Example, simplify the following. Number 1, x into x dash plus y. So it is equal to, if we open the bracket, we have x dash plus xy, and it is x dash is 0. So we have 0 plus xy. So it is OR operation between 0 and xy. So it is equal to xy. Number 2, x plus x dash y is equal to x plus x dash into x plus y, and x plus x dash is equal to 1 according to the basic theorem and postulates, and it is equal to x plus y.